Good evening, everybody. This is Mr. Lowe, your game master. We are working through this quest on volume, and we come to lesson 10-4, combining volumes of prisms. Before we get into today's lesson, I want to just quickly review. We have learned on our journey that volume is the measure of cubic space of an object. We actually measured that using unit cubes. We said we came up with a volume formula, which was volume equals length times width times height. We used that formula to figure out a new formula to find volume of a rectangular prism when you know and understand what the area of the base is. We said that equation was volume equals big B, which is the area of the base, times height. It's still the same thing. Volume equals length times width times height. It's just now with area instead of each individual unit. Today we're looking at combining volumes of rectangular prisms, and this gets us into how do you find the volume of a solid figure composed of two rectangular prisms? So how do you find the volume of a solid figure when that solid figure is made up of two separate prisms? We might have a shape that looks something like this, where we have our rectangular prism, and that rectangular prism is broken down into kind of an oddly shaped prism. And rather than just multiplying all of the numbers that we see, because typically we only look at the volume, the length, the width, and the height, we can't do that with this prism because it's irregularly shaped. So there's two things you can do, and I'm going to do one of them in red. You can take this prism and I can cut the entire top off. So I have two prisms. I have this kind of rectangular prism up on the top, looks kind of like a square, but it's not. So this would be prism A. And then we have this prism on the bottom, and I'm going to write prism B down here so you can see these two. And then we would write the volume equals length times width times height of both of those prisms and find the volume of each. So let's look at volume of A. So I have the volume of A, and I write my equation, length times width times height. And now I have to go figure out what my length, width, and height is for volume A. So my length, and again, long is left to right. At least that's the way I look at it. So this line right here indicates to me how long that object is, because that line goes across the page. So this is 4 centimeters. So I'm going to write 4 centimeters for my length. That also means this line here would be 4 centimeters. This line here would be 4 centimeters. So you can see these are all really the same length of a line. And then I got to find my width. My width gives me that three-dimensional look. That's the line that goes into my page. So my width is 2 centimeters. So I'm going to do times 2 centimeters. And then I need to find the height of that object. And the height of that object will be how tall is it. Now I look, if I chop this off here, I can't say that my height is 7 centimeters, because 7 centimeters is the distance from here all the way down to the bottom. My line only goes from here to here. That's it, which gives me this line right there, which is 5 centimeters. So we're going to do times 5 centimeters. We go ahead and do the math, and I'll do the math out for you so that you guys can take a look at it and see. We get 4 centimeters times 2 centimeters. So those two multiplied together is 8 centimeters squared times 5 centimeters. 8 times 5 is 40. And centimeters squared times centimeters is centimeters to the third power. So the volume of A is 40 centimeters cubed, or 40 cubic centimeters. Now we go down here and we do the volume of B, and it's going to be the same exact process. Volume of B equals length times width times height. And now I have to figure out how long my object is. So again, this one was 4 centimeters. I look down at this bottom rectangular prism. My length goes across the page. That means that one's 4 centimeters. So I'll type in or write in 4 centimeters here. My width, which again, we'll go ahead and change colors to keep it simple. Now I have the bottom. So I want you to look at this. It's the width that goes into the page. It's not going to be this line here because this line stops at the top of that rectangular prism. I have to do this line that goes all the way to the back, which is the same as that line. I'm looking at how long is that bottom pyramid, or not pyramid, that bottom prism. What is the depth of it, or the width? It is 6 centimeters. And of course, we are then going to take a peek at how tall that object is. And again, I look at how tall it is, and it's this line right here, which is 2 centimeters. And now we just need to multiply all of those together. Pick orange. And I do 4 times 6, so 4 centimeters times 6 centimeters is 24 centimeters. And 24 centimeters, 24 centimeters squared, times 2 centimeters is equal to 48 centimeters squared. And what we want to do is multiply, or not multiply, we want to add. We need to add the volume of A plus the volume of B. We can do that. I don't know if purple will show up, but we'll go ahead and do that. Volume of A plus the volume of B. So we have 40 centimeters cubed plus 48 centimeters cubed equals 88 centimeters to the third power. That is the volume of this entire shape. So what we did is we found the volume of A, and then we found the volume of B. We wrote down our equations, and then we added those two volumes together. Now, I do want to point out to you something. You don't have to call this top 1A. Remember at the beginning of the lesson, I said you can just chop the top off. We could have also, if we wanted to, we could have cut the entire front off by dropping a line straight down here. And now I have kind of this taller one in the back, and its dimensions are 4 long, still 2 wide, and now I would use that 7 high. So that would be A. So again, A would be 4 times 2 times 7. And then I look at just this front pyramid, which would now be 4 long by 4 wide by 2 high. And if I calculate those out, I will get the exact same measurement. Okay, so you are going to be doing problems today that look very similar to this, where you are going to decide how to break up that prism. You're going to need to do some of it, a lot of the breaking up piece mentally, but you are going to still need to write down all of your equations and all of your work. That way, if you do make a mistake, it will be pretty easy for me to go back and look and see, because I'll say, okay, well, how did you break them up? Which one's A? Which one's B? And then I'll ask you, what are the dimensions? What's the length? Remember, for us, length should always go across the page. It's just nice that we're all on the same page with that. Width is how deep into the computer screen my object goes, and height obviously is going to be how tall is my object. So we take a look at this. We've got a shape over here. I haven't put any numbers on it, but I could. I mean, we could very easily say that this object is, I don't know, 4 centimeters long there, maybe 10 centimeters here. This one might be 2 centimeters, and this one might be, I don't know, 6 centimeters. And there's a couple of ways we can chop this up. We know that I could break it up where I draw a line here, and I have a thicker rectangular prism on the top, and I have this long, skinny rectangular prism on the bottom. And if we did that, we could say that the top is A and the bottom is B, and write our dimensions, okay? Which is what you're going to do. You will want to do the volume of A, you will want to do the volume of B, identify length times width times height, length times width times height, and that will help you figure out what to do. I'm going to let you go and let you get back to work. Good luck in your journey.